Good afternoon. Let's take a look at systems of linear equations. So for this first video, we're just going to look at systems of linear equations with consistent solutions. In other words, there will be a solution for x, y, and z, or a unique solution. Now normally when I first try to start solving a system of linear equations, I can check here that my first equation given here in this order is 2x plus y plus z is equal to 3. But I do not like the coefficient in the front, so what I can try to do is I can say, sure, I want to rearrange these equations. So if I want to rearrange them, I can write it as x minus y plus 3z is equal to 6. I am going to choose this second equation to start off with because the coefficient in front of x is a 1, so it's going to be easier to work with. Then I can just write the next two equations, 2x plus y plus z is equal to 3, and the last one here, 4x plus 3y plus z is equal to 3. Well, is equal to 3. Yeah, both of them are equal to 3. Okay, so this is what I first do. I rearrange it. I want to make sure that my first equation, if possible, there's no coefficient in front of x. It's not always possible, but if it is, then it is actually easier. What I can do now is I can go and I can label each one of my equations. I can say that this is my first equation, this is my second equation, and this is my third equation. So the first thing I want to do is I want to rewrite my first equation, x minus y plus 3z is equal to 6. I want to rewrite it because I want to be consistent throughout. The next thing I want to do is for my second equation, I want to eliminate my x. So if I want to eliminate this x, I'm going to say the following. I am going to take row 2, which I have here, my second row, and I'm going to subtract twice row 1. So minus 2 times row 1. So 2x minus 2x is going to give me a 0 here. Y minus a negative 2 times a negative y is going to be plus. So it's going to be y plus 2y, and this gives me 3y. Z minus twice of 3z is going to be z minus 6z is going to be negative 5z. And then when I look at my constants, 3 minus negative 2 times 6, and this is going to be minus 9. For my last equation here, how do I eliminate the x? I'm going to say my third row minus 4 times my first row, minus 4 times my first row. 4x minus 4x is 0, 3y minus negative 4y is going to be plus 7y, z minus 4 times 3z is going to be minus 11z, and then if I look at my constants here, 3 minus negative 4 times 6 is going to be negative 21. Now I can relabel them again. Of course my first row stays the same. This is going to be my fourth row, and this is going to be my fifth row. Now what I want to do next, so I can see here I've eliminated x. So the next thing I want to try to do is I want to try to eliminate either y or z. Now I notice here that for the next step I've got 3y and 7y. I want to find the highest common factor between these two because I want to eliminate one of the y's. So what I can do in this situation is I can say, sure, let's do the following. My fourth equation, I'm going to multiply it throughout with 7. So I'm going to say multiply with 7. And then I am going to get 21y, this is a 21y, minus 35z is equal to negative 63. For my second equation, or for my fifth row here, I'm going to multiply it with 3. And then I am going to get here 21y minus 33z is equal to negative 63. So if I want to go and subtract these two equations from each other, I will see here that negative 21 minus 21y is equal to 0. So I'm going to say here, okay, first of all, let's rewrite my first equation, or my first row. X minus y plus 3z is equal to 6. I can rewrite row 4 here. So my first row, I'm going to rewrite it. Fourth row, I'm going to rewrite it. In this case, my fourth row here, I have now I can still say the following, it's still fine. So let's go with 0 plus 3y minus 5z is equal to negative 9. And then for my third row, I have eliminated y. So if I were to go and subtract this, I would be left with, so the y is eliminated. I am going to find here that I'm going to have negative 33 minus negative 35, and this is going to be positive plus 2z is equal to 0. So what I've noticed here is that z is equal to 0. Of course, if I want to simplify this, I can say I can divide both sides with a 2. It doesn't matter, but z is equal to 0. Now the reason why I brought down the first row and the fourth row is because if I find my final solution here, z is equal to 0, I can substitute the 0 into this equation to find my y value. We know that 3y minus 5z, but I have found that z is equal to 0. So 5 times 0 is equal to negative 9. So this is 0, both sides divided by 3, so y is equal to negative 3. Then if I go to my first equation here, x minus, now instead of negative y, I can go and replace it with my y value, in this case negative 3. Plus 3 times z we found to be 0, is equal to 6. So x plus 3 plus 0 is equal to 6. So if I subtract a 3 on both sides, x is equal to 3. So I have found x is equal to 3, y is equal to negative 3, and z is equal to 0. Of course, when you find these solutions, you can also always go and test to see if it is true for all three of my equations. You can go back to your original equations and plug in the values of x, y, and z to see if it holds.